Hi YouTube. So today I'm going to be talking about some good software development principles. This is going to be a, a long video, but not too long, but also a very important video for software developers out there. So I have divided this uh, topic into three sections. The first one is requirements analysis. The second is design. The third is implementation. The fourth is user interface design, and the fifth is project management. So when you're gathering the requirements for the software that you want to develop, it is important to follow these practices so that you do it correctly. And the first is that you should be unambiguous and concise. So your requirements should be brief and straight to the point. You should avoid listing requirements that are uncertain and difficult to understand. So that's for unambiguous and concise. The next is that you should be precise. So a requirement such as in your specification, if you say that the system should be fast, that's not a precise requirement. So you need to say how fast the system should be. For instance, you could say that search result should be returned within 5 seconds. The system should operate at the speed of light. So by saying that, you are precise, and that is important because during testing, the testing teams will be able to measure whether your system is doing what it said it's supposed to do. So if you said that query results should be returned within 5 seconds, so 5 seconds is the parameter that the testing team will use. Next is that you should avoid big requirements up front. That is called BRUF. So when you are speaking to the client, don't try to want to get all the requirements up front, because software development is a continual process. So most clients do not even know all what they want up front. So don't try to list down every possible requirements before moving on to the next phase of the project. Your first set of requirements should just be good enough. It does not have to be an exhaustive list of requirements. So don't try to get all requirements up front. At the level of design, so after gathering your requirements, you're going to produce a specification for the system that you want to build. And after that, you're going to do some design. At the level of design, what should you take into consideration? What are some best practices that you need to follow? So if you are using an object-oriented approach to do your design, the first thing you want to make sure you want to aim for is low coupling and high cohesion. So you need to aspire for that. The next is to model only features that really need modeling. Don't model features that don't need modeling. The third is to make use of object-oriented paradigms. So there's this acronym API, which stands for abstraction, polymorphism, inheritance, and encapsulation. So these paradigms have been proven, they are industry standard. So make use of them. Now to get back to the first point on aiming for so the first point on aiming for low coupling is that the level of dependence on other classes should be very low. In other words, if you want to make a change later, A change in one part of the system should not impact other parts of the system. And cohesion is the level in which a class is focused, so that modifications are done within that class. So if you need to make a change, you don't do it in the class and then you go and do it somewhere else. So aspire for low coupling and high cohesion. And at the level of modeling, you don't need to prepare sequence diagrams for every possible scenario. That is not needed. So just focus on what needs modeling. The purpose of a model is to provide clarity. So if there is some logic that you need clarity, then you can model. If that's not the case, if it's obvious, don't model obvious functionalities. And again, try as much as possible to use abstraction, polymorphism, inheritance, and encapsulation wherever possible. Now, for the third point, which is at the level of implementation. So after you've done your requirements, you've produced your specification document, and you've done your good design, the next is with implementation. That's coding. So what are some things that you should apply to improve your code? The first is the word try. Don't repeat yourself. So do not copy and paste unchanged blocks of codes from one place to another. You should try as much as possible to avoid duplication in code, database, schemas, and documentation. Avoid repetition and duplication. Implement a particular functionality once and use it anywhere else. So you don't need to implement a function here, and in another place you implement that same function. So try to reuse your code. Next is YAPNI. You ain't gonna need it. So don't write speculative code that you might need it in the future. Solve the problem at hand and leave tomorrow's problem for tomorrow. So remove all unnecessary code. Remove all unnecessary code. The next is to avoid very long methods. So if you have a method that is about 400 lines or 1,000 lines, you should start breaking it down into smaller methods. So avoid very long methods. Avoid using very short or very long identifiers. So your variables should be descriptive. A descriptive variable is self-explanatory and thus eliminates unnecessary comments. Avoid long names for variables. Shorter names are important for code readability and maintainability. The fifth is to avoid pointless comments. Don't include unnecessary comments in your code. So for instance, if you have a declaration such as if you declare a variable buff which is of size 10, you don't need to come and comment that this creates an array of integers called buff of size 10. That's a pointless comment. Don't do that. So the purpose of a comment is to improve readability of your code. When your method names are self-explanatory, then you don't need to put unnecessary comments. So portions of codes that are obvious don't really need any comment. So don't do that in your code. After implementation, the next is the user interface design. So what are some things you should apply to make sure that your interface is awesome? The first is usability. The interface of your application should be relatively easy to use. Should be easy to use. The user should not need to read help documents in order to use your software. Your software should be intuitive. A user should be able to see the interface and have a clue on what he or she can do to use your software. The next is affordance. So the term affordance refers to an attribute of an object that allows people to know how to use it. So in simple terms, to afford means to give a clue. So what should you do at this level? Icons should be designed to afford clicking. So if in your interface you have an icon such as this with an X, a user looking at this interface, at this icon would know automatically that this stands for delete. Something like this is for trash. You see, so use uh, icons that give a clue so that when the user view it, he just know what he needs to do. So your icon should be designed to afford clicking. Scroll bars should scroll bars to afford moving up and down. So in most browsers you have the scroll bar at the right and you can use it to move up and down. So if in your application you design a scroll bar to do another thing, it can lead to confusion. So use standard conventions. Buttons to afford pushing. So if in your application you have a button here and then when somebody clicks on it, it instead go to, when somebody clicks that button, you've written submit for instance, and someone clicks on that button and it instead what can I say, someone clicks on the button and it instead delete a record, given that you've written submit here, instead delete a record from your database, that is confusing too. Or you have a button and you instead put a link here. When someone clicks the button and then it goes to another tab, an href link, that's not too nice. So that's not even a too good example, but I hope you get what I'm trying to explain. The next is ergonomics. So the word ergonomics is a study of the physical characteristics of interaction, how controls are designed, layouts and physical qualities of the screen. The arrangement of controls and displays should be appropriate. So the way you position your controls, you don't put a delete button beside a new button, because that might lead to confusion. The user might want to create a record and then he instead mistakenly clicks on the delete button. So you wanna separate the distance between those two buttons. The next is for instance, if you have your USB, you plug in your USB and then you want to eject, it's not too good to have the eject button and the format button together at the same place, because the user might mistakenly click the format button instead of the eject button. So you need to arrange your controls and displays appropriately. The use of fonts and colors, you need to use colors that cannot cause problems to the eyes and health issues. The interface should be readable, and you should also provide the possibility to customize the interface, so the user should have the ability to choose the font or the colors that he wants that is better for his need. The interface should be flexible and customizable to give users the possibility to choose their font sizes, color choices, and that suits their taste. The color should also correspond to common conventions and users' expectations. So we've talked about the requirements and some practices that you need to do at their level in software development. We've also talked about design and some of the practices that you need to apply. We've talked about implementation and some of the best practices that you need to apply at that level. We've also talked about the user interface design. Under this, we've talked about usability and what you need to do to make your application usable, affordance, and economics. So the last point is about project management. It is important that when you are working on a project, you prepare and design an effective project plan. So the benefits of having a project plan is that it will help you to track the progress of your project. It will help you to focus your team on the objectives and to help you be organized. So keep your project plan as simple as possible. Don't overcomplicate it. Your focus when designing your project plan should be on how effective it's going to help your team to achieve their goals. So I hope this short video is informative to you. There is an article that follows this video, and it's devostar.com. So if you visit devostar.com slash good software development principles, you're going to find an article in details explaining these points I've just talked about. I'll also include a link to that article in the description of this video. Please subscribe to my channel, click the like button below, leave a comment with some points that I didn't mention here that you think is helpful in software development. I know there are many more points, but these are some key points. These are some key ones I wanted to share with you. Have a nice time.